I'm Justin from Toolpath. This is a gauge tool, this is a gauge ring, and this video will be the full calibration procedure for this Brother Speedio. So I'm going to take my gauge block stack and put that in the machine using the hand wheel mode. We will jog this over. And what we want to do is get it lined up with the edge of the block. That. And then get it to where the block just doesn't slide under. And we go up till it does. Move this in Y a little bit more, keep it fully on the table. Okay. So that is going under, and that is not. So move it in Y till it just goes under there. That doesn't. That does. Okay, so now we're bracketed in the thousandths. Okay, so that goes. You got to be careful to keep the gauge block flat. That goes. That is very tight, but it does go. And that does not go. So we'll put it right at the one where it doesn't go, because that's the level height. And then you go to the control. Okay, you go to the I/O screen, and then you have to type in the magic code, which is -9999, and hit enter. And then you go to reset absolute encoder counter, basic axes. And you only want to touch the Z axis here. And so you need to type in a number. Now this one has to be in millimeters, but you need to type in a number that matches exactly your gauge height stack plus the height of your gauge tool. So in this case, it's 2.9998 inches plus a 6-inch gauge block stack. Converted to millimeters is 228.5949. Which is what is already in there, but I'll just type it in anyway in case it's a different value. And then you go over here and you type only in this one, you hit 2, enter. You should hear a click and see it go right back to 0, and now your encoder is calibrated for Z. All right, after you calibrate your Z encoder, the next part depends a little bit on which macros you have. But for the macros that were given to me, for this Speedio, the next step is to set your tool offset. And I've loaded this into tool 20. So actually I'll type 20 and hit search. And there is a tool length offset in there. I'm just going to zero it out and instead type 2.9998 and hit enter. Completion mode, cancel with saving changes. And then I need to go manually position the tool over the tool setter, trigger the tool setter, because that's how these macros are set up. They want it to start initially triggered, and then run the calibration program. So the calibration routine for me is 8003. That's the program number. And then I need to go into manual mode and jog the tool over to the tool setter. That'll just take me a moment here. So there we go. You can tell it triggered from the red light. So this is how these macros want to start. And we just run the calibration program. Now for these macros, and again it may be different depending on which macros you use, that stores the location of the tool setter and stores the height offset for the tool setter. And with that, we are done with the calibration tool, the gauge tool, so you can take that out of the machine if you want. And we'll move on to calibrating the probe next. Now it is really important that you calibrate the tool setter before starting in on the probe, because the very first thing we're going to do is measure the probe on the against the tool setter. Now there is some controversy about whether or not you should be measuring your probe against your tool setter. I'll come back to how we deal with that in a second. The controversy comes from the fact that there's a spring in the tool setter and a spring in the probe, and there's some uncertainty about which one wins in that situation. But in this case, the process does have a way to compensate for it. So the very first thing you want to do, and we use tool number 99 for our probe, so the very first thing you want to do is zero the length offset so that you know this works. Throw that tool in the spindle. If you're using, make sure you have the right tool number selected. Go to your tool setting program, which for my macros is program 8000, and then run the tool setting program. Now I'm gonna shoot over to here so that we can see this change. Okay, so that is the length offset for the probe as measured by the tool setter. Now there is a small amount of error in there, and we're going to account for that in the next step. Okay, this should be pretty universal, although you can configure it a little bit, but for the Bloom macros, the default is to store these probe offset values at 500 through 505. So we'll see these fill in as we run through the calibration process. Okay, the next step after you've zeroed out these variables is to get your gauge ring in the machine. There's a couple different ways to do this. You could put it on some magnets or create a pallet. I just use like the lightest pressure in the vise, just enough to take like all the motion out of it. And that's all you need. Just like a hair past the weight of the tool. And then we will jog the probe down into the gauge ring. get it reasonably centered. That's not close, so we'll get it pretty close. Make sure the probe tip is below the height of the gauge ring. And then we're going to run program 701. And this is for probe tip calibration. But you do need to set this variable 904 to the correct value. Now in this case, my gauge ring is 39.9999, so now we want to convert that to inches, and that becomes 1.5748. Completion mode, cancel with saving changes, because brothers are weird. And now we can run this program. And this is calibrating the diameter of the probe. Spins around 180 to account for any run out in the probe. Hopefully you've already dialed in the probe before that. And now we can go back to these macro variables and we see that it's dialed in the trigger range and added, well, actually, yeah, 4/10 run out, I guess. Yeah, so you'll see these numbers start to change as we dial these in. This last one, 505, is where we account for the trigger distance, or the distance between the height of the probe as measured by the tool center and the height of the probe triggered by like a gauge artifact. Okay, now we're going to put our gauge artifact, 6-inch artifact back in the machine. Gauge block stack back in the machine. Leave the gauge ring in for now. It won't hurt anything, but you're basically done with it at this point. And then handle mode. I'm going to jog over. Get the probe centered over there. Positioned over the gauge block stack. And now we're going to do 702. So we go to memory mode, 2, and hit enter. Got it, so it's got to be within ½ an inch there. Now you do need to set the calibration service height in G58Z. So for this macro to work, we have to go to here and here. And in this case, I happen to already have it, so I wasn't using G58 for anything else, but you're typing in calibration height here. So if you used a different gauge block stack or a reference artifact with a different number, you'd do it here. This is in inches if your machine is in inches. So I think we're good to go. We are on program 702. So we run that, and while we run that, we will watch the macro variables change. So there we go. That became like 1 thou and 2/10, 12/10. So that is the difference between the probe height as measured by the tool center and the probe height as measured by that reference artifact. And so that should be independent of the probe tip that you put on there. So this number should be relatively universal unless you get a new probe or something changes. It's just a function of the springs in your setter and the springs in your probe. If you get a new tool setter, you move things around, you'd want to redo this, but this number should basically never have to change. And so now the nice thing about doing it this way is that if you put a different probe in, or you want to recalibrate your probe mid-run for like Z spindle height growth from like thermal growth or something, you can now just run your probe on the tool setter to get a valid height because this is accounting for the error between the trigger height and the tool setter height. So this value, if you didn't have anything set in the tool length, would be equal to the gauge offset of the tool at its triggered height. But since we have a gauge value measured on the tool setter, this is now sort of the trigger distance, if you will. And so with that, we've done the Z encoder, the probe. So with that, we've done the Z encoder, the tool setter, the probe diameter, and the probe length. And the machine should be accurately calibrated now.